So this is where we actually left yesterday. We were doing division of two polynomials, px with gx. The first thing we wanted to do was we wanted to arrange the polynomials or write them down in such a way that the powers of the variable are in decreasing order. In case there is a term missing, we would represent that term with zero coefficient. So as for now, I have written the quadratic and the linear polynomial px and gx respectively in decreasing order of their powers, which is also called their standard form. And then I've started with the division. We have done the first step by calculating the first term of the quotient, then multiplying that term with our divisor, and we have completed the first step. After completion of the first step, we wanted to obtain the second term in the quotient. So whatever we are left of our dividend, हमारे पास dividend में से जो कुछ भी बचा है, at the second step we will be using that. This is what's left of our dividend, minus 2x minus 1. So to obtain the next term of the quotient, we are going to use the first term from this leftover part of dividend. Whatever is left is the first term divided by the first term of our divisor, and we would obtain the second term of the quotient. And the second term is minus 2. I had put this minus 2 in my quotient over there. This is something which is missed while doing this work, sometimes doing it quickly, right? So be careful. Once you have obtained the next term, the next step will be to multiply this minus 2 with the divisor. Just take it a little here. So after this, I'm going to multiply my divisor with minus 2. And I'm again doing this in the working column. My divisor is x plus 1. I'm going to multiply with minus 2. You can do this orally again, if in your mind, if you want. It's not necessary. That's correct. So minus 2 multiplied with minus 1 will be minus 2. Then minus 2 multiplied with x will be minus 2x. And let's list this down here. And then the next step will be to subtract. And when you subtract two algebraic expressions, the signs will be changed. So this minus changes to plus. The second minus also changes to
plus.
Now you can solve minus 1 plus 2. Plus 1, and the terms containing x will get cancelled. Minus 2x with plus 2x. These get cancelled. So you can now write down what the quotient is. The quotient of your division is 3x minus 2. And usually we represent the polynomial in the quotient as qx. Q for the quotient, and since the polynomial is in x, we will write down qx. And then the remainder, which is actually a constant here, I can write the remainder as Rx. Remainder could be 0, remainder could be a constant, or a remainder will be a polynomial whose degree is less than the degree of your divisor. Division का जो rule होता है आपके पास. Yes? I'm sorry?
We will divide till when?
ओके डिवीजन का रूल जो होता है, नॉर्मली जब आप नंबर्स की डिवीजन करते हो, नंबर्स की डिवीजन आपकी तब रुक जाती है व्हेन यू आर फिनिश्ड विद द डिजिट्स.
Remainder is 0.
Actually no, remainder is not necessarily 0 for every division, because you have done divisions where the division goes on continuously, right? डिवीजन का रूल होता है कि जब आपके पास डिजिट्स खत्म हो जाएं, फर्स्ट कंडीशन, एंड द सेकंड थिंग इज द रिमाइंडर इज ऑलवेज लेस देन योर डिवाइजर. So if I have to take an example, let me take an example here, just a minute. So let's say you have 723, it's to be divided by, let's say 5. So you write down the first part, 5 ones are 5, आपने subtract किया, you left with 2. The next step is to bring this 2 here, you get 22. What will be the next digit in the quotient?
420.
Okay. What next?
3.
So right now it should be, it should be 5 4s are 20, right? It should be 5 4s are 20. But what if I do this?
dividend will be increased.
This is wrong. This is wrong because the remainder is greater than the divisor, right? So the correct part would have been, or the correct answer would have been using a 4 here, and then you would be having the product 20, the remainder would be 3. There are certain conditions which are applicable to the division that you perform, that either the remainder is 0, in which case your division is complete, right? Or the remainder is less than your divisor. Along with this, there is a condition that needs to be satisfied. It is your dividend should be equal to the product of divisor and quotient and the remainder added to it. ये आपका जो डिविजन चेकिंग वाला रूल होता है, ये वेरीफाई होना चाहिए. ये भी वेरीफाई होना चाहिए और उसके साथ आपके पास रिमाइंडर पे ये कंडीशन अप्लाइड है. Like whenever you see some advertisements जिसमें offers होती हैं, they always say conditions apply. So the rule that follows every division follows this rule, that the dividend is equal to divisor multiplied by quotient plus remainder. चाहे आप numbers की division कर रहे हो, चाहे आप polynomials की division कर रहे हो, ये rule हमेशा true होगा. आप डिवाइजर को क्वोशिएंट से मल्टीप्लाई करोगे, उसमें आप रिमाइंडर को ऐड करोगे, तो आपको आपका डिविडेंड वापस मिलना चाहिए. एंड the condition that applies while checking this is the remainder needs to be either equal to 0 or the value of the remainder should be less than the divisor always. It cannot be greater than or equal to the divisor. It will always be equal to 0 or less than the divisor itself. This is a condition जो हम usually लिखते नहीं थे. हम सिर्फ ये लिखते हैं d equals to small d multiplied by q plus r while checking the division. There is a condition that applies to this rule or the verification for division, that the remainder is 0 or the remainder is less than divisor. Numbers के लिए हम इस तरह से लिख देते हैं, लेकिन जब हम polynomials के लिए लिखते हैं, so polynomials के लिए representation थोड़ा सा different हो जाएगा, because we are working in terms of a variable. We do not have the actual values. So if my dividend has been represented by px and my divisor has been represented by gx, I should have the dividend px should be equal to the divisor gx multiplied by the quotient that I obtained plus the remainder. This is the remainder. And the condition which is applicable while checking this, that either rx, the polynomial, remainder polynomial, should be equal to 0 or the degree of this polynomial should be less than degree of your divisor. पॉलिनोमियल्स को छोटा बड़ा कैसे देखते हैं हम? डिग्री की टर्म में देखते हैं. सबसे छोटा आपके पास कांस्टेंट पॉलिनोमियल होगा, उसके बाद आपके पास लीनियर होगा, फिर क्वाड्रेटिक होगा, फिर क्यूबिक होगा, सो ऑन. तो जब आपको ये बोलना है कि जो रिमाइंडर आया है वो डिवाइजर से छोटा आया है, तो आपने ये लिखना है, डिग्री ऑफ द रिमाइंडर शुड बी लेस दैन डिग्री ऑफ योर डिवाइजर. This is division algorithm for polynomials, and you're going to study this in detail later in, I think, class 10th. Right now, we will be only applying this. इससे ज़्यादा काम नहीं है इसका. आपको सिर्फ इसको अंडरस्टैंड करना है कि जब हम डिविजन चेक करते थे फॉर नंबर्स, हम इस तरह से लिखते थे, कैपिटल D इक्वल्स टू स्मॉल d मल्टीप्लाइड बाय कैपिटल Q प्लस कैपिटल R. You are aware of these representations, I hope. Anyone who does not know what these capital D, small d, capital Q and capital R mean, please let me know. अगर किसी को नहीं याद. और जब हम पॉलिनोमियल्स के साथ काम करेंगे, हम कैपिटल D, स्मॉल d, कैपिटल Q, कैपिटल R नहीं लिखेंगे, हम पॉलिनोमियल्स के नाम लिखेंगे. And the usual representation, I'm not saying this is fixed, this is the usual representation कि हम अपने डिविडेंड को px लिखते हैं, डिवाइजर को gx लिखते हैं, कोशेंट के लिए qx और रिमाइंडर के लिए rx यूज करना है. And we need to apply a condition while writing this rule of division that the remainder polynomial should either be 0, means आपकी division complete हो गई, नीचे कुछ भी नहीं बचा, the remainder is 0. The second possibility is the remainder is always smaller than your divisor. Now, in case of polynomials, we cannot write that down because we do not have actual values of the polynomials. So I will be working in terms of degrees. The degree of my remainder will be smaller than the degree of my divisor. Anyone with any questions? Going back to the division that we just did. So right now we have completed this division and the remainder, as you can see, is 1. Now there will be questions जहाँ पे आपको ये division करनी पड़ेगी. I will let you know. Second thing, लिखा होगा question में carry out the division. The third question where it's optional, whether to carry out the division or whether to use a shortcut, is the next result that we have. Now, what I want you to focus on here, आप पूरी division जो है उसको अभी आप ignore करो. Only focus on the remainder that is left. The remainder left here in this particular division is 1. I want you to just observe something. My divisor was gx equals to x plus 1 and the dividend was px. The value is 3x square plus x minus 1. Is that right?
Yes.
Without actual division. Without actual division, I can find the remainder obtained. So the first step will be to take divisor equals to 0. So x plus 1 equals to 0. This implies x equals to 1. Take your divisor equal to 0 and find x. So that means x plus 1 will be equal to 0. From here, x comes out to be 1. The second step is equal, says put the value of x obtained in step 1 in the dividend. So we will be using x equals to minus 1 in px. So this would mean p of minus 1. The representation changes when you replace your variable. 3 into minus 1 square plus minus 1 minus 1. What do you think about this? Without performing actual division, you can find out the remainder when a polynomial is divided by another polynomial. Is this making sense? Like, do you follow what I'm saying here? हमने division तब तक नहीं करनी जब तक हमारे पास other options available हैं. Like either the question says carry out the division, तब आपको करनी पड़ेगी. The second question is where you will need to do it because उसके बिना काम ही नहीं चलेगा. You will learn that later in the exercise के कहाँ पे division करना compulsory होगा even if it is not indicated anywhere in your question. पहला देखो, first type is where it's indicated in your question, you have to do the division. Second, it's not indicated in the question, but in order to do your question, it's necessary to carry out division. Those are the two options where division will be must. But the third option is where you can avoid the division, and this is what we are talking about. अगर आपका कोई polynomial is being divided by another polynomial and you only need to find out what the remainder is. सिर्फ आपको रिमाइंडर बताना है और कुछ नहीं चाहिए, क्वोशंट नहीं चाहिए, पूरी डिवीजन नहीं चाहिए, सिर्फ रिमाइंडर चाहिए. What you can do is you can use this shortcut. Take your divisor equal to 0, obtain the value of x from there and use that value of x in the polynomial which needs to be divided. That's your dividend. And you will be able to obtain the actual remainder, which would have been there if you carried out in the division in real. Anyone with any questions?
Yeah.
Now this result that I have stated, the shortcut that I'm talking about, this shortcut is actually stated as remainder theorem. So that's what I'm going to now. A remainder theorem is given in your book. It's on page number 39. So remainder theorem says let Px be any polynomial. This is your dividend. Its degree is greater than or equal to 1. This means it is either linear or quadratic or cubic or biquadratic, or degree is 5, degree is 6, so on. Not a constant polynomial. Degree is greater than or equal to 1 means that the dividend is not a constant polynomial. And we are dividing this polynomial by a linear polynomial. This is very important. The divisor is a linear polynomial. And the linear polynomial is given as x minus a. And the remainder can be obtained by using this result here, which says remainder is P of A. तो किया क्या इन्होंने? The first step is to take the divisor equal to 0. So x minus a will be equal to 0. From here, value of x is equals to a. As step 2 will be to use this value in your dividend.
Excuse me, ma'am.
Yes.
Ma'am, why the divisor should be linear?
The divisor should be a linear polynomial because from a linear polynomial, you can obtain a single value, right? But if it's quadratic or cubic or of higher degrees, you will have multiple values. Then you would not know which value to be substituted in order to obtain the correct remainder. आपने कल मेरे साथ क्वेश्चन किया था ना जहां पे आपने क्वाड्रेटिक पॉलिनोमियल की जीरोस फाइंड की थी.
Yes, ma'am.
क्वाड्रेटिक पॉलिनोमियल की जब आप जीरोस फाइंड करोगे, यू विल बी टेकिंग दैट क्वाड्रेटिक पॉलिनोमियल इक्वल टू 0. वहां से आप उसको फैक्टराइज करते हो इनटू लीनियर पॉलिनोमियल्स एंड देन यू गेट टू वैल्यूज. So you cannot use that polynomial which has multiple zeros to use remainder theorem. Remainder theorem can only be used if any polynomial other than constant polynomial is divided by a linear polynomial which will only give you a single value of the variable. Because हमने अपने divisor को equal to 0 करना है, वहां से x की value निकालनी है, तो हमारे पास एक unique value होनी चाहिए जो हम अपने polynomial में put करके remainder find कर लेंगे.
What is a constant polynomial?
Constant polynomial is a polynomial which does not contain any variable, just a number. Constant term होगी just polynomial में, उसको constant polynomial बोलेंगे.
Okay, ma'am.
So you just need to know how to use this result other than whatever is given here. So right now we will be going to apply this. We're just going to apply this in order to do a question here. Now there is an example given below right here to apply this theorem. There is a polynomial which is divided by x minus 1 and you need to find out the remainder. So the simplest thing that you will do is without doing actual division. You are first of all going to represent your dividend by px, your divisor by gx, and then you will follow the steps as indicated above. So step number
Excuse me.
1, yes?
And we always have to divide by x minus 1.
No, 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 no. The divisor could be any linear polynomial. It is going to change later. Like if you take a look below at example number 10, this is your divisor here. It will change. But it will be a linear polynomial.
Okay.
It will change, but it will always be a linear polynomial. So you have to take your divisor equals to 0. From there, obtain the value of x. So right now in example number 9, my divisor is x minus 1. I have taken it equal to 0. From here, the value of x is 1. Step number 2 is to use this value in the dividend. Dividend is px. So by remainder theorem, remainder will be equal to p of 1. So let's just substitute. We have 1 raised to the power 4 plus 1 raised to the power 3 minus 2 into 1 square plus 1 plus 1. And then you can just simplify. This will be 2 minus 2 plus 2 and the answer is 2. अगर आप पूरी डिवीजन करोगे एक्चुअल में तो आपका तब भी आंसर यही आएगा, बट हम इतना काम करने की जरूरत नहीं है क्योंकि सिर्फ रिमाइंडर चाहिए, हम ये शॉर्टकट फॉलो करेंगे. Anyone with any questions? What the result is, how to apply it? All right. Let's do exercise 2.3, page number 40. Find the remainder when this polynomial is divided by these linear polynomials. So I'm just going to do it on a side here. This is page number 40 in your textbooks. So question number 1, I'm going to represent my dividend by px if anyone, okay, is my voice audible?
Yes, ma'am.
Yes, ma'am.
Yes, okay, okay.
Ma'am, do we have to do something before 2.3 about
No.
remainder?
No, 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 no. You don't need to do anything. You can just mark it in your book.
Okay, ma'am.
So the first step is to represent your dividend by this name px. And then for the first part, your divisor is gx equals to x plus 1. Now, if you want, you can write down step 1, step 2, but I'm just going to do it directly. So I'm going to take gx equals to 0. This is my first step. From here, x comes out to be minus 1. I have written a note here. Let me know if this makes sense.
Yes, ma'am.
Yes, ma'am.
Remainder
Yes,
is
ma'am.
0 means your division is complete. If the division is complete, that means by whatever value we were carrying out the division, the divisor is now a factor of our dividend. ये बिल्कुल सिंपलेस्ट डेफिनेशन है फैक्टर की कि अगर हम दो वैल्यूज को डिवाइड करते हैं और रिमाइंडर 0 आ जाए तो डिवाइजर इज एक्चुअली कॉल्ड द फैक्टर ऑफ द डिविडेंड. This is something you will need to write down in third question. Check whether 7 plus 3x is a factor of 3x cubed plus 7x. Anyone with any queries with respect to the application of remainder theorem? I hope it's clear. Yeah. Okay,
Yes,
let's just quickly do these side by side over here. So you can do it on your own from your book and I'll be doing it here and then you can match your answers with me. So the px is same, which is x cubed plus 3x square plus 3x plus 1. And for the second part, my divisor is x minus 1, right? So solving, take your divisor equals to 0. And then by remainder theorem, we can find out the remainder.
Excuse me, ma'am.
Yes.
Ma'am, while solving 3 into 1 by 2 whole square, we
Sorry,
need
it
to
will be
write it
4, 3
3
by
upon
4.
4.
Yes, it will be 3 by 4. I have written wrong. Can you tell me what's the simplified answer for this? This will be 8, 1 plus 6 plus
27
12
by 8.
plus 8. Okay, so now we have gx equals to x plus pi, and I've told you you have to use pi as such. You don't have to use the value of pi. Just work with x equals to negative pi. The first step is to take your divisor equals to 0. So x plus pi will be equal to 0. This means x equals to negative pi. And then by remainder theorem, the remainder will be given by substituting this value in px. And you're going to give the answer as such. That's it. No simplification required.
Can you show the third part?
Sure. Is it done?
Yes, ma'am.
So let's do the second question quickly here. You have to find out the remainder when this polynomial is divided by x minus a.
Excuse me, ma'am.
Yes.
Ma'am, please admit Sukhraj.
I have. Yeah, I've
Okay,
admitted
ma'am.
him. Yeah. Okay. So the dividend has been represented by px, the divisor by gx. The rule says take your divisor equal to 0, obtain value of x, and in order to find out the remainder, use this value in your dividend. So by remainder theorem, the remainder will be given by putting x equals to a in px. Okay, everyone pay attention here. Question number 3, where you want to check whether this polynomial is a factor of the other polynomial. It's important to identify which of these will be your divisor and which of these two will be your dividend. So जिसको हमने check करना है whether or not it is a factor, it will be considered as your divisor. And जिसके लिए consider करना है, that will be your dividend. So I've just written it simply here, but this is not how you will be writing down. You will be taking your dividend as px, the usual representation. So this is how I know that this polynomial is my dividend. And I'm going to take the divisor as gx, and then I'm going to follow my remainder theorem. And what I am looking for is the remainder to be equal to 0. By applying remainder theorem, if the remainder comes out to be 0, I will say that gx here is a factor of px, else the answer will be no. So there are two ways your remainder theorem can be used. First of all, to find out the remainder when division of a polynomial is done with a linear polynomial. Second, to check whether a linear polynomial will be a factor of some other polynomial given to you. So from here, x comes out to be minus 3 by 7, and remainder will be given by p of minus 3 by 7.
Excuse me, ma'am.
Yes.